Now, looking at my third method of solving differential equation. So now, this method, we are going to be solving basically homogeneous equation. Now, I'm going to define what a homogeneous equation is. A homogeneous equation is an equation in which the, the two implicit functions you are given, they are of the same degree. Now, what am I trying to say? If you are given a function of m xy, that's a function of m, which is a function of x and y, and x and y, these two particular functions must be of the same degree. Now, what is a degree? A degree is the power of those functions, the power in the equation of those functions. Let me take for example. Now, given x squared plus y squared, what is the degree of this equation? The degree of this equation is 2, because both x and y are having a degree of 2. So basically, if the two equations you are given, they are of the same degree, then you call that a homogeneous equation. Why? Because now, why are we trying to solve a homogeneous equation? For example, looking at, if you are given dy dx is equal to xy, that's the y dx is equal to x squared plus y squared over xy. Now, you can't solve this by separation of variable, because the function of x and y are both accumulated together, and the same goes for this. You can't also solve this by direct integration, because this is an implicit function. So how do we go about it? You check if it is an homogeneous equation. Now, looking at this particular function here now, I can call this has a degree of 2. This is 2 x raised to power 2, and this is y raised to power 2. Automatically, if they are separated by a plus sign, this particular equation is having a degree of 2. Now, looking at this particular equation xy, this is also having a degree of 2. Why? Because this is xy is x is having a degree of 1, y is having a degree of 1. So 1 plus 1 gives me 2. So basically, these two equations are having the same degree. Then I can solve by homogeneous equation. I think I can solve this homogeneous equation by substituting this particular function. Y is equal to Vx. So now, I'm going to give you the steps in solving homogeneous equation. Now, the first step in solving a homogeneous equation is to check if those equations are homogeneous. How do we check if those equations are homogeneous? By checking their degree. If they are of the same degree, then they are homogeneous equation. Then your second step is by substituting y with respect to Vx. So now, let's take this example. Dy over dx is equal to x plus 3y over 2x. Now, we have to solve this. Now, your first step is to identify if they are homogeneous equation. So, looking at x plus 3y, this is of degree 1. And the same goes for this. This particular equation here is also of degree 1, because x is of degree 1. So, these two equations are of the same degree. So, basically, they are homogeneous equation. So, my second step now is to substitute y with respect to Vx. But before I substitute, let me differentiate it. So, y equals Vx. This is what we have to substitute. So, differentiating y with respect to Vx. Now, the second step is to differentiate it. Then your third step is to substitute it. So, let me differentiate y is equal to Vx. dy dx. Now, assuming where v is a function of x, where v is also a function of x. So, now, taking v to be a function of x, I'll apply my product rule. The short formula for product rule: v, take this one as constant, differentiate this one, differentiating x, which is 1, plus, take this one as constant, hold x as constant, differentiate v. Differentiating v, which is also a function of x, will be regarded as dv dx. So basically, my dy dx is equal to v plus dv dx in x. So this is what I have. So now, this is my second step. My first step is to identify if it is a homogeneous equation. So my third step now is to substitute this function here into the equation. So I have dy dx is equal to, anywhere I see y, I put vx. So this is x plus 3 bracket vx over 2x. So now this is dy is equal to x plus 3vx over 2x. Now I can basically write this as taking, this is x plus 3vx over 2x. Now since x is both common in these two equations, I bring out and factor out x. This is 1 plus 3v over 2x. X will cancel x. So basically I have 1 plus 3v over 2. So now dy dx is equals to 1 plus 3v over 2, and also dy dx is equals to v plus dv dx. So I equate the two equations. Remember, I'm actually looking for v. This is the equation I'm actually working for, is y is equal to vx. This is the equation I'm trying to look for. So for me to have that complete equation, I have to know what v is. So that is what I'm trying to look for. I'm trying to look for the value of v. So now equating the two equations. This is dy dx is equal to v plus dv dx multiplying x, and I got dy dx to be 1 plus 3v all over 2. So now equating these two equations, I have v plus dv dx x is equal to 1 plus 3v over 2. Taking v to the other side, this is dv dx x equals 1 plus 3v over 2 minus v. Then I can basically say divide this v over 1, right? So this is 2 brackets, 2 into 1, that is 1 plus 3v minus 2v. So this is 3v minus 2v, that's 1 plus v over 2 dv dx. So that is that taken. So now, what do I do here since I'm looking for my value of v? Now, so from where we stopped, so now we have dv dx x equals 1 plus v over 2. Now for this particular equation, we are going to apply separation of variable. Why? Because we are having dv with respect to x, and we are having a function of v right here. So this is my function of v, and this is a function of x, or x. So I'm going to apply my separation of variable. Why? Because that is the only method I can be able to use. I can be able to use to solve this particular equation. So if I apply separation of variable, now taking the one for v to the other side and taking the function of v to the other side, so this is basically saying, this is basically saying dy dv over dx times x equals 1 plus v over 2. So to solve this, I have to take my derivative of v to the function of v. So taking this particular function to v, I'll have dv over dx, right? Now taking this one to v, this automatically gives me 2 over 1 plus v equals x equals 1, right? So taking x to the other side, this is dv over dx, open bracket, 2 over 1 plus v equals 1 over x, right? Taking it to the other side. So now taking the x to the other side, this is just basically multiplying 1 over x. So this is dv over 2 over 1 plus v equals 1 over x dx. Right, so I have successfully separated the two variables, successfully separated functions of v and functions of x. So now what's the next step is to integrate both sides. So integrating both sides, this is integrating both sides. I have integral 2 over 1 plus v dv equals integral 1 over x dx. So, like I said, integrating a linear function is the natural logarithm of that function. So this basically gives me 2 ln 1 plus v equals, now integrating, this is also a linear function, integrating 1 over x, this gives me natural logarithm of x don't forget your constant, plus c. Now, for case of uniformity, I can basically express a constant as another constant. What am I trying to say? I can say let c be equal to ln a. This is also a constant and this is also a constant. So expressing a constant to be in form of another constant, you can also do that. So for the case of uniformity, I have 2 ln 1 plus v equals ln x plus ln a. So applying my law of logarithm, I have ln equals x a, right? So this is 2 ln 1 plus v. Now rewriting this, applying law of logarithm, I can basically say this can also be expressed as ln 1 plus v raised to power 2 equals ln xa. So ln will cancel ln, right? So this is 1 plus v over raised to power 2 equals xa. So taking the square root of both sides, right? Taking the square root of both sides, I have 1 plus v equals root xa, right? So taking 1 to the other side, this is v equals root xa minus 1. So I've gotten my value of v. Now remember, this is the equation I'm working with, y equals vx, right? So bringing this particular equation here, I have root xa minus 1 bracket x, right? So this is root xa minus root xxa, right? X will multiply this times 1, this is x, right? So now taking x to the other side, this is y plus x. If I'm not mistaken, this is y plus x equals x root xa, right? So I can also say that taking square root here of both sides, I can actually leave my equation like this. This is a perfect equation. I can also choose to simplify it further. So this is taking the square root of both sides. This is y plus x all square equals x square times xa, right? So I can basically say this is ax raised to power 3 y plus x square. I can also leave my equation like this. You can express this equation in any form, but mostly I advise you should express it in a more simplified term. So this can be also, you can also express it like this, or you can also express it like this, whatever way you choose. Now going to our fourth method of solving differential equation by integrating factor.